Welcome back to topic 5.8. For this lesson, you're going to need the notes, your periodic table, and then a highlighter will also be useful for this lesson. So we're going to talk about ions. So we've talked about ions before in terms of the structure of the atom. So this first little bit is going to be a review in that we looked at the atomic structure and the idea of protons being our positively charged subatomic particle is going to equal the number of negatively charged electrons to make an atom neutral. And so we did establish that that is not always the case. And so elements like to either gain or lose electrons to get to the point of having this stability, not nuclear stability, but still stability in its configuration and to fill those valence shells like the noble gases. So what we have, the rule is called the octet rule. And so the majority of the elements would like to obtain 8 valence electrons. So that would fill the 2 in the s and the 6 that go in the p orbitals and combine together to again give you 8 valence electrons like the noble gases. And so elements have the ability to gain electrons, lose electrons, or share electrons. Depending on where they're at in their configuration, that will decide which is easier or the most probable configuration to make it to the point of getting 8 valence electrons. There are some exceptions. So those first 2 elements in the first period, hydrogen and helium, they only have that first 1s orbital. So they don't have the octet rule. They have what's called the duet rule, meaning that they want 2 valence electrons. And then lithium and beryllium, if you look at your periodic table, they are found really shortly on in the periodic table. And so it's easier for them to lose electrons to become like helium. And so they also follow the duet rule. So everything past atomic number 4, so 5 through 118, are going to want an octet. So that's the main goal today, is looking at our 2 types of ions and determining which is easier for an element. Is it easier to become a cation, or is it easier for it to become an anion to get to that point of having stability? And so when we take a look, cations, again, those are the positively charged particle, or not particle, but ion, and it's because there's a loss of electrons. And so that means that an element has more protons than they do electrons, and that's why it has a positive charge. Anions are the opposite then. They are negatively charged because there's a gain of electrons, meaning that electrons in number are greater than the protons. And so that's where we get our 2 ions. So this is just a review from last semester. So what we're getting in today that's new is looking at what is easier for an element to do to get to that octet rule. And so the first thing we're going to do is work on it through the perspective of Bohr models. And so this one wants us to start out by drawing the Bohr model of sodium. So to do that, we're starting with a neutral sodium atom. So we have sodium is atomic number 11, meaning that it has 11 protons, and to be neutral, 11 electrons. So we're going to start with our Bohr model. So we have our first ring here. And if you remember, the first energy level is made up of just the s, so it can hold 2 electrons. Moving on to the next energy level, that is made of the 2s and 2p. So that can hold a total of 8 electrons. So that gets us to 10, which means the third energy level, which can hold 18, only needs the 1 and it's full. For those of you that are new to having me as a teacher this semester, if you did Bohr models in the first semester, what I like to do is just one little extra thing, is I like to highlight this outermost ring just to indicate that this is our number of valence electrons, okay? So we have 1 valence electron. So the next question then is, for sodium, it has 2 options. It can go through the process of gaining electrons, or it can go through the process of losing. So the idea is, how many does it need to gain and how many does it need to lose to get to that complete octet? So right now it has 1 valence electron. So to get to that 8, that means it needs to gain 7 electrons. If it loses an electron, what would happen is it would lose this outermost valence electron, moving it to the second energy level, which is full. So it would only have to lose one electron. So the question is if you are sodium, which is easier to obtain, that octet, finding 7 electrons or just getting rid of one? And so what that looks like is we can draw the Bohr models real quick for these two options. And so we still have those first two rings are going to be the same in the gaining process. And then what we can do in the next ring is we're going to fill that with 8 electrons because it's picked up 7 more. So that's what that configuration would look like. And again, you can go through and add your highlighting. And again, we're looking at achieving that octet rule. So by gaining 7, that's one way to fill that octet rule. And then to lose 1, we will just have 2 energy levels. And we will fill that outermost shell. And so again, if you were in sodium's shoes, which would you rather take? And so hopefully you can see that probably the easiest of the two is that losing 1 electron is going to be the easier pathway than finding 7. So what's going to happen here is Na is going to lose 1 valence electron to become, well, it lost 1 electron, so it became a +1 cation. Okay. And so the other way we can look at it is why an element would want to form an anion or a negative charge. And so our example here is going to be for an oxygen atom. And so oxygen, if you look at your periodic table, is atomic number 8. So that means a neutral oxygen to start has 8 valence electrons, or 8 total electrons, not necessarily valence electrons. So 2 of those 8 electrons are going to go in that first ring. The second ring to get us to 8 will have 6. And so again, I can highlight my outermost ring here to identify my valence electrons. And so I have 6 valence electrons. Again, 8 total electrons, 6 of which are valence. And so just like sodium, you have 2 options here. You can have a gain of electrons or you can have a loss of electrons. So if you were to go through the pathway of gaining, we're at 6. So that means to fill its octet, it needs to gain 2 more electrons to fill that shell. On the other hand, when you lose, it's going to lose all of these valence electrons to move to the next inner energy level to again get to an energy level that is already full. So the other option here is to lose 6 electrons. And so you can't just give these up. You have to find somebody, and by somebody I mean another element, to take in those electrons. So looking at the Bohr model here, if we had that gain take place, and if we have a loss, we would have just this ring here. And so again, if you want, we can go through and highlight, and this would get us to 8 valence electrons for the oxygen. The loss would take us to 2. So again, which pathway is going to be easier for oxygen here? It's easier to gain 2 electrons than it is to lose 6. And so what's going to take place in this scenario is oxygen will gain 2 valence electrons to become a -2 anion. So again, when it looks at this pathway, whichever is going to require the fewest electrons, either in a gain or a loss, is going to be the pathway it's going to take. So it took fewer electrons through gain here, and it took fewer electrons through loss for the sodium, and that's why they choose those pathways. So the last thing we're going to do is take kind of the shortcut method and look at it through a Lewis dot diagram. So the last thing I want to reiterate here is the idea that these configurations all end in the same. If you remember over here, this is our S block, this was our P block, this is D, and down here was F on our configurations. And the one thing I had you do last semester was look at the pattern of the periodic table. And so you saw that all of these ended in S1. These all end in S2, P1, P2, all the way ending here at P6. So that means, like I said in yesterday's video, that all of the elements in a family, that vertical column, have the same number of valence electrons. So because these are in family 1, they end in S1, it's easy to look at their family number and you know that has 1 valence electron. These end in S2, so that means these have 2 valence electrons. The D block does things weird with valence electrons, so we can't predict those easily from the periodic table, and we'll get into why later on. So when we jump over here to the P block, we have the S is filled and 1 in the P orbital. And so these have 3 valence electrons. So my trick to really easily, quickly predict valence electrons is you just cover up the 1. These all have 3 valence electrons. Family 14 has 2 in the S, 2 in the P, so they have 4 valence electrons. So what I'm getting at here is these have 1, 2, just like their family numbers. When you get to the double digits, if you just cover up the number, we have 3, 4, 5, 6, 7, 8. The only exception that it doesn't work with is helium. It's placed here because it's full, but it only has 2 valence electrons. So again, you don't have to draw a Bohr model necessarily or a Lewis dot structure in order to predict valence electrons. So real quick, we're going to look at Lewis dot structures. And so we're going to start with fluorine. It asks, what's the number of protons? So it says a fluorine atom, so that means that it's neutral in charge. And so it has 9 protons. Therefore, it's going to have 9 electrons, and the net charge is going to be 0. The dot diagram is just the valence electrons. So we have F for fluorine. Fluorine is a halogen in family 17. Therefore, it has 7 valence electrons. So I'm going to show those 7 dots around fluorine. So it asks for a fluorine ion. So when it comes to protons, it's going to stay the same. So now we have the same idea, is we just have an abbreviated Bohr model, and so we only have the valence electrons. So we are looking at what's easiest for fluorine to complete its octet. Is it easier for it to gain or lose? So if it goes through the loss, it has to lose all 7 of these electrons. If it goes through a gain to fill this octet, it only needs to take in 1. So again, it's always going to go with whatever is easiest, a gain or a loss, that involves the fewest electrons having to move. And so it is going to definitely be easier for fluorine to take in 1 electron than for it to lose 7 of them. So I'm just going to show that new electron in a different color to indicate that is the one that was gained. The other thing we do, and so the electrons, is we gained 1. So the total number of electrons is now 10. So the net charge is a -1. So what we do when we have a Lewis dot structure that's charged is we draw it in a set of brackets and we put the charge outside of it. So we show fluorine in the brackets with a -1 outside. One last example is the lithium atom. So lithium is, when it's neutral, it has 3 protons, therefore 3 electrons, and the net charge is neutral, so 0. So lithium, and same idea is I can add my valence electrons here. So 1, 2, or let's see, I'm adding all my electrons. I don't want to add all my electrons. So lithium is in family 1, therefore it has 1 valence electron. So let me go back real quick, and I'm going to just scratch this out. So we have 1 valence electron. Again, dot structures only show valence electrons. I was attempting to show all of them. Okay, so if we were in lithium shoes, it has 2 options, gain or loss. If we go through the gain method, it would need to gain 7. If it goes through the loss method, it only has to lose 1. Which is easier? It's going to be the loss. And so what we do here is lithium is going to ultimately get rid of this 1 electron. So for its structure is it's not going to have any valence electrons left because it's given it up. So lithium still has 3 protons. It now has 2 electrons because there was a loss taking place. So it has more protons than electrons, so it's a +1, and I'll show a +1 charge here. So the last thing I want to do real quick before I let you go is I want to kind of help you get started on your homework, just to kind of get you started. So this first page here is just filling in information from the front side, and what we've just done with the Bohr models and that. I want to talk a little bit about the second page of the homework. And so it asks atoms with 1, 2, or 3 valence electrons. What are they going to do with their electrons? So again, which is easier to get to that octet if you had 1, 2, or 3 valence electrons? Is it easier to gain to get to 8 or lose to get to that 8 from the inner energy level? So these are going to go through a loss of electrons, or they're going to lose electrons. And so the next thing is, what kind of ions do they form? So if you are losing electrons, that means you have more protons than you do electrons. So they become cations. And what's the charge of a cation? They are positively charged. Okay? For this table, there's a few things that are going to help you with this. So the first thing is, you have that periodic table that you colored where you identified where metals, nonmetals, and metalloids are found. That periodic table is going to be useful for you. So if you take a look, potassium, its group number is here, so it's in family 1. And so because it's in family 1, that means it has 1 valence electron. So what it likes to do is it likes to lose 1 electron to become K with a plus charge. That means it's a cation. It's asking if potassium is a metal or a nonmetal. So potassium on this particular periodic table that I have in this book is color-coded green, which means it's a metal. And so I'm going to just put M for metal. And what it means by left or right is which side of the periodic table is it found on, and it's found on the left-hand side. For oxygen, what you would do is you would see that oxygen is here in family 16. So it's in family 16 or group 16, which means it has 6 valence electrons. So what does it like to do to get to that octet? It likes to gain 2 electrons, making it an anion. If you look at the color coding system, it's blue. Therefore, for this one, it's a nonmetal. So I'm going to put NM for nonmetal. And it's found on the right-hand side of the periodic table. So I'm going to do just one last one with you to make sure that you're understanding this part of it. So magnesium, it's found in family 2. That means it has 2 valence electrons. How is it going to get to that 8? Is it going to go through a loss or a gain? So it would have to gain 6 or lose 2. So this is going to lose 2 electrons to become Mg plus 2. It's positively charged. That makes it a cation. If you look at your periodic table, magnesium is in the green, just like potassium was. Green means that it's a metal, and it's also on the left side of the periodic table. So if you have any questions or concerns regarding this assignment or the topics covered, please reach out to me.